So because this produces an ionic substance, then we can't say that one atom of potassium and one molecule of oxygen produces one molecule of potassium oxide. But what we can say is that 1 mole of potassium reacts with 1 mole of oxygen to produce 1 mole of potassium oxide. Now, so and the next thing to know is, well, what is a mole of this? What is a mole of that? What is a mole of that? Well, by definition, a mole is a certain number of atoms. So it's actually 6.02 times 10 to the... So a mole is that many atoms. But it just so happens that when I take that many potassium atoms, it will actually weigh the same as its atomic mass, 39. So a mole of potassium is 39 grams. And we can write that by saying mR, which means the molar mass, of potassium is equal to 39 grams. So we can do the same thing with molar mass of... And when we write oxygen as a word, we may not know that it's supposed to be O2, and then we might end up writing 16 grams, but that would be wrong because that's the molar mass of oxygen atoms when oxygen behaves as exists as molecules. So it would be 32 grams. So because it's a 1-to-1 ratio, then you could do the maths, but clearly we would add them together to say the molar mass of potassium oxide is going to equal to, well, 71 grams. So in other words, so if I had 1 mole of that and I had 1 mole of that, I could produce 1 mole of that. Now I can say if I had 39 grams of that and I had 32 grams of that, I could produce 71 grams of that. Or I could say if I had 39 grams of that and excess oxygen, I could produce 71 grams. When I say excess, I simply mean more than enough. I've got enough oxygen to react with the potassium. Or I could have 32 grams of this and excess potassium. I've got more than enough potassium to react with the oxygen. So, and then obviously I'd have leftover of one of them if I had excess. So what they want you to do with moles is they would give you different amounts. They wouldn't give you 39 grams. They'd give you something really strange, like 16 grams of potassium. So if we know it's a 1-to-1 ratio, we would need to know how many moles is 16 grams. Well, we can work this out by, if we know that 39 grams is 1 mole, then we could imagine a scenario in which the mass... When the mass is equal to 39 grams, then the moles is equal to 1 gram. So, and we know that molar mass is equal to 39 grams. So then we just sort of give ourselves an easier problem. So what about if it was, it's not 1 grams, but what about if it was exactly double? So 78 grams. Well, clearly the moles would be 2. So how did I work that out? How do these numbers relate to each other? Well, it's going to be the moles is equal to the mass divided by the molar mass. So once you've seen the formula, and obviously eventually you'll just memorize that, then you can put it into a triangle. So mass at the top, mole and molar mass at the bottom, and then you would just rearrange it. So now you can say, how many moles is that? 16 grams. So we've got the mass is 16 grams, so you're going to do, so the moles is going to be 16 divided by the molar mass. So 16 divided by 39 is 0.410256 recurring. Well, basically, let's just say that's equal to 0.41 mole. So that would mean that I could react it with 0.41 moles of oxygen. So depending on what question they ask you, they might say, how many grams of oxygen could you react it with? So you would first of all work out how many moles of that in order to find out how many moles of the oxygen. And then from that, turn that moles back into grams of oxygen. So we've got 0.41 moles of oxygen. We use this over here. The mass is going to be equal to the moles multiplied by the molar mass. So 0.41, I can keep it in the calculator to reduce the rounding error, times that by, and the molar mass of oxygen, 32. And I've got 13.1 grams. So 13.1 grams would be the answer. If they were asking that question, if they were asking how many grams of oxygen would react with 16 grams of potassium, the answer would be 13.1 grams of oxygen. Does that make sense?